This is question 36 from the GATE 2020 EC paper, where we are provided an enhancement MOSFET with a given threshold voltage, and it is used as a sample and hold transistor. We are asked to find out what the minimum and maximum values of VG are required for proper sample and hold operation. Underneath the question, you will find the title of the NPTEL course or video that is relevant to this question. The only background that you will need for this question is the NMOS drain current equation in its various regions. Pause the video at this point to assimilate this. So let us look at the solution of this problem. The idea is for sampling, the MOSFET needs to be in on state. That is, its VGS should be greater than VT. Right? For VGS less than VT, the current is 0, so the voltage will not be sampled onto the capacitor. Right? So for this current direction, this is the source, this is the drain, and this is the gate. Right? And if the above inequality is satisfied for maximum source voltage, then it is sure to be true for other voltages in the range provided. Right? Now when the MOSFET is on, VD equal to Vs is equal to the input voltage Vi. Right? This is so long as the VGS is greater than VD. Right? Because if the VD was not equal to Vs, then the current ID would be there would be a non-zero current ID for as long as the VDS is non-zero. So only when the VDS is equal to 0 will the ID be equal to 0. So when the MOSFET is on state, we assume that the capacitor will charge up to the drain voltage, provided of course that VGS is greater than VTH, and so therefore VD will equal to Vs, and since VD is Vi, VD equal to Vs equal to Vi. Right? So the inequality now becomes Vg greater than Vs max plus Vt, which implies Vg greater than 10 plus 3, which was the respective which is the respective input voltage maximum value and threshold voltage. Right? 10 plus 3, so Vg has to be greater than 13 volts. Right? This is so that VGS is greater than VT. Right? For hold state, the MOSFET needs to be in off. So now we get that VGS has to be less than VT. So VGS minus VT less than VT. VG minus VT less than VT. So VG is less than Vs plus VT. Now of course, if the above inequality is satisfied for the minimum source voltage, then it is sure to be true for other voltages in the range provided. So therefore Vg has to be less than Vs min plus Vt, and which is minus 10 plus 3, which is minus 7 volts. Right? Therefore the correct option is C, 13 and minus 7 volts.